Hi, everyone. Good morning, good afternoon, and good evening. We are going to start the episode 8 of Anyone Python today. So it's almost last week, next week. So we are going to end the season 1 with episode 10. Then I'm not sure when I'm going to start the episode season 2 or not. So we will see later. Okay. So as usual, please stretch. So with your preference. Okay, before we start, so today also we have a lot of things to do, and it's much more fun. I think we pretty much covered most of the thing with the Carol today. Then we can understand how we can use the Python with the help of Carol. Then we will solve the several problems next week. Okay, so. And if you do not download it yet, so please download the AnyPython E08.c file, then save to the Anyone Python folder. So as a user, we are going to use the Anyone Python folder under your desktop, and we are going to use it for today's lesson. Okay, so then let me quickly check the attendance. Unji, our TA, she is now available today, and Trinity may join today, but I cannot find her name. So if you have any questions, please use the chatting box, but I may not respond right away, so I will take care of that after the class. So if you have any questions, so please be patient if you do not receive the answer from the chatting box, okay? So I'd like to share my iPad. So, okay. Then, so let's continue the last talk. So last week, last episode, so we have seen why the computer likes the binary number, why the people use the decimal number, 10-digit number. Okay, so today we are going to continue the discussion about the binary number. How? So last time we understand why we computer likes the binary number. That's because of the current. So using the current, we can represent the two different signal like this. So we can say that this is the 0 and this is a 1. Or vice versa, something like that. Because of this, so we can use such a binary number. Then today we are going to see how we can use such a binary number system for our computer before we go forward. So I think that some of you, I think the Trinity may join. So let me check. Okay, so let me change her status as the co-host. Hi, Trinity. Okay, so you guys can ask a question if you have using the chatting box. Today the Unji is not available, so please ask to Trinity. Okay, so I think that probably some of you may not understand exactly what is a binary number system. I'd like to remind you, you're the elementary school, the math class. Okay, so for example, in the number system first. What is the number system? For example, the human being, for example, as we discussed the last time, the human being likes the 0, 1 through the 9, 10 different number. Okay, why the 100? Why not the 1,000? Because it's too many. Because people can use the 10 fingers, something like that, and the 10 thumb. So only the 10 number, but with the 10 different number, it's limited. So people think about how we can extend such a number. So at the time, as we know, there is the concept of the digit. So for example, if we have the number 1, 2, 3, 4, this is not just number 1, 2, 3, 4. This one, there is not just 1, it's 1 times what? Anyone? Each digit has the value, right? For example, this one is a 10 to the power of Anyone can answer? So 1 is not just 1, it's 1 times 10 to the power of 3, which means this is the same as 1,000. So similarly, the 2 is not just the 2, it's the same as, what's the value of the digit? It's a 10 to the power of 2. As you know, it's a 10 to the power of 3, 10 to the power of 2, 10 to the power of 1, 10 to the power of 0. That means the 1, like this. So that means the 1, 2, 3, 4 is not just the 1, 2, 3, 4. Instead, it's the 1,203, the 30, the 4, so such a number, such a value. So we can add up the multiply the value, so 30 and 4. So finally, it can have such a 1,234 value. That is the number system. Specifically, this is called the decimal number system. So, but as we have seen the before, computer, the electric device, don't like the 10. It's too much complicated. Instead, it used on, as you know, what is the number that are used for the binary number system? It's only 0 or 1, the 2 number only. Unlike the decimal number system, the binary number system has only the 2 different number, but it used the exactly same, the digit. So for example, if we have the one, oops, so S 1101. So this is not the 1,101 number, because this is the binary number system. Each digit has a different value. It's the same idea, but slightly different. This one has a 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3. So as you know, the exponent is increase, like that, 0, 1, 2, 3. So if you add up all of this, so what's the value? Is the, anyone who can calculate it quickly? What's the value of this one? It's a 15. Let's see. So 2 to the power of 0, 1. This one is a 2 to the power of 4. 2 is a 4. This one is 8. So 8 plus 4 plus 1 is almost, but not 15. It's a 13. So value of this is a 13. So we can use as you learned in the algebra class in your elementary school. You can actually exchange it, interchange the binary number system to the decimal number system, decimal number system to the binary number system. It's not very easy, but you are able to do. If you cannot remember that, why don't you look back the math textbook, or if you do not know what is the binary number system to the decimal number system, or vice versa, please ask your parent or ask your sibling, ask your brother and sister. It's not the rocket science, unlike the SpaceX. So it's just a simple math system, but it's very, very useful to understand the computer binary number system. So we are not going to use this one. Instead, we are interested in such a binary number system. Specifically, so let me simplify a little bit, erase this, okay? And this. Yes, so then, when we are using in mathematics, each number is the digit, as I introduced. But in computer system, each number is called, from now on, is a bit. So, for example, in this case, how many bits we have? How many bits? Oh, the second. So second thing is, it's a 0. Even though value is 2 to the power of 2, but it's a 0. 0 means nothing. That's the reason I didn't add up, okay? So each one is a bit. So how many bits we have here? How many bits? It's a 4 bit. So instead of digit, computer use the name of bit. So bit, bit, bit. So bit means representing either 0 or 1. So when you talk about I have the 64-bit computer, which means 64 number, 64, 0 or 1 will be processed, calculated at the same time. Okay, so each one is called a bit. So this one is also bit, and this one is called also bit and the bit. So the reason why it's called the bit is, you know, the bit is like what's the impression of the bit? It's a small, okay? So that is the reason we are using. It's a smallest storage, okay? Smallest storage of the binary number. It's called a bit. And then bit can represent either 0 or 1. It's too small, okay? Yes or no. It cannot represent, it cannot show the picture, it cannot show the video. So we need a little bit bigger. So a little bit bigger, the concept that is by combining 4 bit. So we are going to call the 4-bit as the, anyone? It's called the nibble. Oops. It's called the nibble. Nibble is the same as a 4-bit. So in this case, this is the 1 nibble. So 1101 is a 4-bit is the 1 nibble. But so nibble is not very used. So you don't have to worry about it. Even you can forget about what is the nibble. Instead, usually we are using 8-bit. So this is the total 8-bit. So 8-bit, this is the 8-bit as the byte. So this is called the 1 byte. So in computer system, to represent any data, we need at least the 8-bit or 1 byte. Okay, so 1 byte means 8-bit. That's the reason. So when you connect the internet speed is sometimes to exaggerate. They use the bit. So my computer speed is 32 mega bps. At this time, B means the bit. It's not byte. So actually, the real speed should be divided by 8. That is the 4 megabyte. Okay? So you don't have to be confused or the fool. So when internet company show their speed, they are using the bit because it's 8 times, looks like 8 times faster. So what we are going to use in computer system is the byte. So byte is the byte. 1 byte has how many bit? 8 bit. That's correct. That means how many 0 or 1? How many binary number we need? 8 binary number. Okay. So let's see. There's such an example. So such an example. So why don't you open your oh no, not yet. So let's see for example, see this one. Anyone who knows what is this? Anyone? This one. It's a disk. Correct. Very nice, Justin. Actually, disk is being used for this. So anyone who can guess what is this? This is the hard disk drive. Yes, correct. So hard disk, actually the inside, if you open, so if you have the unused or old hard disk drive, if you open the case, actually it has a lot of the disk inside. So inside the disk, so it's like the orbit. So you have a lot of the orbit here. So if I draw that like this, so like that, then actually this one has, if I zoom in this surface is like this. Then if you burn or if you write the data, it will be changed like this. Okay, at this time, so this one represents 0. This one 1, this one 0, this one 1, this one 0, this one 1. So this means 0, 1, 0, 1, 0, 1 data like this. So computer actually use this or hard disk drive use if you can represent either yes or no, 0 or 1. So turn it on, turn it off. You can actually represent a binary number, right? So think about what kind of example you can use to represent a binary number. Anyone? So for example, so if you turn, I'm going to turn off. This is a 0, and this is the 1, and 1, and 0, 0, 1. So even we can use such a turn off, turn it on to represent the binary number. Or as you can see over here, so you can use such the thing. And this idea also use your memory. So we talk about what is a memory in the first class. So memory is like the what? Anyone who can remember what is my definition of the memory? Anyone who remember? It's a container. Yes, correct. It's like the drawer. Okay. So, but it's a very well organized container or storage. So somebody draw like this. It's like the grid style. So we can actually use the storage to represent a value like the 0, 0, 0, 1, 0, 1, 0, 0. This is a 1 byte. Second byte is a 1, 1, 0, 1, 1, 1, 0, 0. Whatever the meaning. So you don't have to worry about the meaning right now. But we can store how can you represent a 0 or 1? At that time, we use electronic signal like this. So we can send the signal like the 1 and the signal 1, then that will represent the 1 or the 0 like that using electronic signal. So we can represent each bit value, then 1 represent 1 byte and 2 byte, 3, 4. Total this memory has the 4 byte data. Exactly same on your cell phone. Exactly same thing on your laptop. Exactly same thing on the PC. So computer use such a binary number is very important. Why we need to understand the binary number? Because computer can understand only this binary. Just like when you make the friend. So you have in your class you have really nice boy or the girl. So I try to make a friend. So you should know them first. Okay, if you get along with the computer, you need to understand how computer is the thinking or how computer is the processing. So that's the reason, that's the way how computer is using the binary number. The problem is, can you understand the meaning of this one? Anyone? Nobody. Even I don't know what's the meaning of that. So to understand right now we understand how computer is using binary as a byte, but we don't know the meaning. So to understand the meaning, there's a really nice fancy way. So why don't you open the browser? So let me change the share. Let's see my favorite desktop sharing. So can you see the web browser? Okay, probably. So search. So ASCII, the conversion chart. So please type on the search the ASCII, the conversion chart. CONVERSION chart. okay? Or table. Table is fine. So why don't you type, then search. So you will see the bunch of the, just click the first one. If you click the first one, so you will see this. This is called the ASCII conversion chart, ASCII table. So what is an ASCII? Anyone who heard about what is an ASCII? Anyone? It's a code, very nice. The Sean, very nice. It's a code. It's kind of the secret code between you and me. So if you have a girlfriend, so you set up the secret message, like the one knock is means the I'm here. So two knocks is something different meaning. Like the it's agreement, it's a secret code. Like the computer and human being set up the such a the code, like this one. Okay, so let me make it bigger for your the better understanding. Or not this. So hopefully yes. So let me clear the annotation and see that this is the ASCII table, but it's not such a big. So let me. So please use the ASCII code table. Let for example this one. So here. So this is a binary. As you can see, how many number, how many digit can you see for the binary number? How many digit? So count it. 1, 2, 3, 4, 5, 6, 7, 8 number. Right, so it's an 8 number. So 1 byte is enough to represent what? Here. So for example, A is, so it's a 65, A is here. The capital letter A is 0, 1, 0, 0, and 0, 0, 0, 1. This is from now on A. Okay, capital letter A. So what about the capital letter, the O? Capital letter O is 0, 1, 0, 0, and you can see 1, 1, 1, 1, 1, 1. So 1, 1, 1, 1 is O. So for example, if I convert high in binary number, high. What is the binary number for high? So why don't you find capital letter H and I? So why don't you find it? And meanwhile, I'm going to change it. So if you just take a look at the screen, so you do not have a chance, please use your computer and search the ASCII code conversion chart and download or use the web browser and to find it. Okay, do not rely on my screen. Okay, so let me change here. Done. Okay, anyone? Oh, already did. Amanda said 01001000, and Daniel said I is 0100100001. Let's see it together. Okay. So for example, the high. When we are saying the high, where is my pen? Yes, H and I. Okay, so what is the H? Let's find the H. H is, where is the H? Capital letter, yes, it's a 0, 1, 0, 0, and 1, 0, 0, 0. And I is, it's a small letter I, it's a 0, 1, 1, 0. Then 1, 0, 0, 1, right? So if you want to say, yes, very nice, I think the Claire is correct and the Pierce is correct also, very nice. So this is a high. Okay, then if you know this one, you can actually use this. How many bit? It's 8 bit. It's a 1 byte data. So you can store this one on the CD or hard disk drive. How? For example, the H is like this. So it's a 0, 1, 0, 0, 1, 0, 0, 0. So this is a 0, 1, 0, 0, 1, 0, 0, 0. You can write it this way, and computer can read. How can computer read? There is a razor. So razor actually read this one. It's a short. It's called the flat. And this one is length. It's a deep, and this computer understand. This is 1 and 0, 1. Okay. Then do you remember the computer communicates, send the data and receive the data using bus? Do you remember that? There's a bus. Bus is a highway, right? So if your computer is an 8-bit computer, 8-bit computer, this 8 number at the same time, because as I said, bus is a highway for lane to send the bit by bit data. So 8 number will be sent together. It's an 8-bit computer. Question, what about the 64-bit computer? How many bit can send the data at the same time? 64-bit computer. So most of you has a 64-bit computer. How many bit? How many? 64 bit. In other words, 8 bytes of data sent all together. It's a very fast, much more fast. That is the reason we have not just the 32-bit, but 64-bit computer like this. This is the way how computer is processing. But one last thing. So we can use such the ASCII conversion table. But what about the number? Number. So what about the number 10? So if you are using ASCII code table as 10, let's use the 9 first. So if you are using the ASCII code table, 9 is what? You can search the chart. It's a 0, 0, 1, 1. Okay, 1, 0, 0, 1. So this is the ASCII code. And this is the decimal number. So 9 will be like this. However, when we are using the ASCII code, it's not actually number, it's a character. It's the letter 9. It's not number 9. So number 9, so integer number 9 will be stored. First, convert the binary. So like the 1, right? And so this is a 1001 binary. So at this time, when computer store the number, computer does not use ASCII because they don't need the code because the number can be changed directly to the binary number. So actually the computer just store the 1001 for number 9. However, if you want to store the character string number 9, so computer use this one. Don't be confused. This is a very important concept later when we learn about the variable. So in variable, number 9 and string 9, they are different. And also, this is the reason why we call the string. For example, Li is the string. Why is it called the string? String is a string, right? Thread. Why? Because L is one code. L is one code. E is one code. E is one code. It's a string of such a binary number. That is the reason it's called a string. So string is the series, the sequence array of such a binary number. Okay, so we will see the evidence, the why. This is important. Next class, the next week. Okay, that's it. I know some of you may not fully understand. What the heck is that? So this is very complicated. So if you don't understand exactly what is the binary number, how the binary number is stored on computer, and also the conversion table, forget about it. Even without understanding this one, you can continue to work for the Python. However, if you understand the way how computer is using binary number, later it's much more easier to understand computer program itself. Okay, so this is the ASCII code. Then I'd like to introduce today's problem based on that. So let me quickly change the sharing. Okay, so today's problem is, oops, not this one. So it's called invert beeper. So invert beeper means, so it's very simple. The carrot is moving from here to the end of this is called the east side. East side means it's until it meets the word, okay? Then, why the carrot is moving toward, if there is the beeper, pick up. Okay, if there is the beeper, pick up. Otherwise, which means it's no beeper, put beeper. It's an invert. So final output is like this. As you can see, the first one, no beeper, so output is yes beeper. Second is yes beeper, so pick up beeper. Third one, no beeper, so put beeper. And yes beeper and pick up. Pick up, this one, no beeper, so put beeper. So very simple, but how can we do that? So we should know whether there is a beeper or not. In other words, so we need to test the function. We discussed last time the test function. So Carol provides very nice the test function. Several things. Do you remember? Why don't you go to the reference? So if you open the browser, let me clear this. Please open your browser. If you just watch the voice, it's a waste of your time. Please open your Carol site. I'm going to share this link again. So if you go to the Carol site, the reference means it's like the cookbook. So you don't have to memorize. Instead, whenever you need, you can search, look up. So you can see here, there are several test function. So let me explain this using this, not this. Every time this one is open. So where is my yeah, not this. Oops. I may close this one. Let me hold on. Oh yes. So I make it right. Yes. So this is the summary of the Carol test function. So Carol provides this nice function. So let's see the front is clear. So we used this one last time. So when Carol is moving, whether it's blocked or not. So we pretty much need to use this for the last one. So for example, where is the problem? Oops. Yeah, here. So carol is approaching. If approaching the end of word like this, how does the carol know? At that time, we can use the front is clear. If front is clear, it return always either the true or false. If blocked, false is returned. So this side is the opposite function of the left-hand side. So you can understand easily. So second function is a be present, which means if there is a present, like the, for example here, so we can use that function, whether there is a beeper or not. If beeper, yes, true is returned. If not, no beeper is a false, will be returned. So we can use the beeper present, true or false. There are more. So for example, the next one is the left is clear. So carol is moving this way, for example. Okay. Then left-hand side, this is my side, and the left-hand side is here. If left-hand side is clear, the true it will be returned. For example, in this case, so carol is moving this way. So which means this is the left side. This is the right-hand side. This is the behind. So whether left is clear or not. In this case, it's clear. So yes will be returned. So that is another function. So right is clear. It's similarly right-hand side. And beepers in back. Whether beeper has a the carol has a beeper, then this will be true. Facing north. This one shows the direction. So as I explained many times, so this is the north, and this is the south, this is the east, and this is the west. So using this function, we can recognize the direction of the beeper at the carol. Okay, so you don't have to memorize this. So just keep your mind. Then we are able to use later. So let's clear everything and start the program together. So as a user, let's start the pie chart. Okay, start. I will give the time to start the pie chart. Okay, then open. Always, if you successfully save and unzip, you need to go to the desktop, anyone Python. Then, oh, I didn't unzip. So I'm going to unzip this. Yes. Then, so anyone Python, any Python E08, just select this folder, then open. So meanwhile, I'm going to share the iPad again. I'm going to introduce one of the most popular, the Python command, which is called done. Okay, so this is called the if statement. If is a condition. So if there is the beeper, so like for example, if beeper present, then we can do if statement, if command. This one is called the block. So for the block, as we learned many times for space, the indentation. So if true, if statement is true, statement or test function is true, then run this one. Okay, very simple. Then don't forget, we need to use colon here because this is the indentation block. If block start, so colon means if block is starting. So let me clear this and this. So this will run. So you can put the test function here, test. Very simple. So for example, so in our case, if beeper is there, so how can we write? If, well, we can use a beeper's present. Beeper's, the present. Don't forget the colon. Then what? We need to pick up. Pick beeper. That's it. Very simple, right? So let's go back to the screen. Yes. So let's start. Let's test. Start the invert beeper. As a user, we don't need the path. So if beeper present, don't forget the colon. Then what is the action command? Pick beeper. That's it. Let's run the program. Then run program. Is it okay? Something wrong? It's okay. But we just checked the first one. So we don't know whether it really works. So let's move one more. So second, so we can move, then run it. Let's run the program, run. Yes, you can see the carrot pick the beeper. So move, then there is the beeper, so move. So one more time. Let's show, run, pick. So that's good. However, we don't want to manually everything, right? So what will be ideal? What can be the idea to cover, to pick the all of this? Anyone? Anyone? So we can use while loop. Do you remember the while loop? So we can make this one as the definition. So what? So let's say the invert the beeper. Then like this. This is the new function. Then we are going to this function for while. While what? Until front is clear. Front if keep doing until when? As long as the front is clear. Then for what? We are going to call the invert beeper. Then move. So this is what we learned the last time. So while loop, keep doing as long as it's true. Front is clear. So if blocked, then the while loop will be ended. And the meanwhile, so every time while loop called the invert beeper, right? So let's run the program. Let's run the program here. Yes, but something wrong. Don't you think that it's working well? Any idea you have? Anyone? Yes, because our problem is if there is peak. If there is no beeper, we need to put, right? Invert. So, but this one just a peak. So we are going to change the code slightly. Let's change it to the iPad again. If it's not that's not the only the statement. If has the else. So else means if not. In English, the if something otherwise we use a lot. Otherwise, it's exactly same. If this is not true, otherwise else. So we can use else. In case of else, so we are going to learn the else statement like this. So for example, if we continue this one, if beeper is present, pick beeper else, so we can put beeper like this. That makes sense, right? So we can put beeper else in case of else, otherwise. But there's one thing, I made a mistake. What is the problem here? Anyone? Colon, right? So don't forget every time. Before you start the indentation, always put the colon. Then computer, Python know where is the starting of the block statement, else block statement. Let's go back to, so why don't you change your code? So please change your code. Please change your code. So we can change here else. Keep in mind, the else is this line indentation because it's not part of the inside of the if. If else is like the same level. Okay, that's very important. It's a very common mistake. Then put beeper. That's it. So looks like wonderful. So next, just run. Be brave, okay? No matter what kind of code you have, just run. Then see what's going on. Run the code. Put, pick, put, pick, put, pick. Yeah, it's almost. Do you think it's perfect? Is it perfect? Not quite, right, Justin, Claire. Anyone? So who remember name of this problem? What's the name of this problem? It's called the fence post problem. The post always one more, right? The Claire, Amanda, very nice, Justin, and Katie. So fence post problem. So problem is the last one. So we need to do one more thing of what? Invert the beeper here. Invert beeper. Let's run the code. See, run program. Yes, see what's going on. Looks good, looks good, looks good. Yes, it's a put beeper. So finally, so it works. Very nice. So please complete up to this code. I will give the 1 minute 30 seconds to complete this one. So please, if you are done, please give me the thumbs up. Then I can see how many of you are following me. Okay, so very nice, everyone. And anyone else? So Claire, very nice. And Chang, did. Very nice. So let's stop the sharing, then see the clear how many of you are following. And Katie did, very nice. Anyone else? Hey, if you are wrong, keep the revising your code. It's totally fine. So Amanda, very nice. Hey. Justin finally did, so very good. Okay, then I'd like to introduce, because that's what I prepare for today, but because you are so good, I'd like to introduce one more technique for the if statement. If statement is the most used in any computer programming, okay? So let me change the screen to the iPad again. I need an efficient way to swap. Okay, so this is the summary of what we learned today. If, then test function should be always true or false. That's important. Then don't forget this. And also we have here we need the if statement in case true. And also we learned else. And don't forget this. And you can put the else command here. However, condition is not always just one condition. Sometimes think about if the beeper exists. If not, check the left is clear or right is clear. And keep checking. So in case. So we can add the multiple, the condition. One way is you can use multiple time, if else multiple time. But we don't want such a complicated. It's stupid, the repeated. Instead, Python provide else if. Then you can put the test. Then, hold on, and also command. So you can use the if, or sometimes called the else if you have multiple condition. So which means you can put one more, else if, and test. If true, and run. Two of them. If you want, one more. If you want, 100, 1,000. So if is just one time. However, else if multiple time, if you have multiple cases. But there's one very important thing. So if this is true, so this is run, what happened? Python do not check this, just end this, like the else. If false, check the next else if. If yes, next command out of if. And if false, and next. Finally, else. So this is the complete syntax rule of if, else, elif, and else. This is a complete code. So it's very easy. But this if statement is mostly used one. Okay, so you can practice more with what? With this carol test function. So you can check for example, front is clear and front is blocked. Oh, let me change it. Oh, you cannot see my screen. So let me change the screen here. So you can use any carol function. So for example, if you want, so it doesn't make sense, but I can show the example elif, the example, so you can put such an elif as many times. So beepers, if no beeper, I know this doesn't make sense, but so this one shows how the elif or else if is working. Okay, just for fun, run this program. I'm not sure whether it works. I just randomly create. So let's see whether it works or not. Oops. Yes, and run the program. Something looks like the working, so it's fine. Okay, so then one more thing. One last thing is I'm going to clear this, and then this is our code. We do not know whether it works with a different character word. So let's try to run this program with a different word, like for example, the road. You can click the load word and going to the desktop, anyone Python 8, and there's a word. So I have the several different invert beeper word. So let's try the 7x7. So this one is different from the 8x8 previous one. So run the program, whether it works. Yes, it works. So if you want, you can change. And this time the 3x6. Does it work? Let's run the program. Yes, it works. Even the 1x1. Do you think the 1x1 is working? What do you think? Is it working or not? Let's run the program. Yes, and so there was no beeper. Then when I run, it's inverted. There is the beeper. So computer, when you code make the computer programming, when you run the computer programming, your program should work in general, not very specific case. Sometimes you can limit the condition, but most of the case, your program is running in general condition, like any different shape and any different cases. So your program should work. Okay, so that is the reason we do not use the first method, move, 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 turn left, move, move, move. Instead, we are going to control using if statement and loop, in loop, for loop, and while loop. And the difference, for loop, if list is fixed, when we know the list. Otherwise, if we do not know just condition, then we can use the while loop. So loop and if statement is very, very important, not only Python, but any program language we use a lot. Okay, so that's the end of today's lesson. Oh, challenging problem. I think the last time that I gave you the challenging problem. So because of a short amount of time, I'd like to just give you a hint, then you can solve the problem. So we can put the beeper all around the side. How can we do that? We can use the loop again, right? Specifically, full loop is better. Why? Why? Why the full loop is better than the while loop at the time? Why? Because we know it has a 4 side. So we can range just a 4. Then 1, 2, 3, 4. If we do not know how many sides, then while loop is better. right? Or with the yes, true or false. So that's the challenging problem last time. So we can this time. So please review the other, because the next week we are going to start with a little bit challenging problem on the episode 9 that combine all together that we learned so far. Okay, please review. And if you don't follow the 100%, please follow the review and the follow thing. And so one last thing is I'd like to launch the poll. So please give me your impression, how did you feel today's class? Then that will be helpful to prepare the next class. Thanks so much for your attending. And I know the most of state in United States, the stay at home is released, but be careful and stay safe. And we will see on Tuesday for episode 9. Thanks so much. This is today's result. Half of you really like it, and 80% like it. So if you are so please review the previous one. Thanks so much. Trini, thank you. Yeah, the Winji was not able today. I know that you probably busy today. Okay. If you have any questions, please ask to me or the Trinity using chatting box. Let me stop the recording.